Hey scholars, I hope things are going well for you so far this school year. For this lesson, we're going to go a little bit further into linear functions. We're going to talk about how to graph them, and we're also going to talk about how to write an equation for them. So even though this might feel like some review for maybe pre-algebra or algebra 1, you'll still need to take good notes and pay close attention to this lesson. Let's get going. So let's start by checking out this example of a linear function. We can see that this belongs to the linear function family. The parent function of the linear family has been reflected across the x-axis because we see that a is negative. The absolute value of a is 1/3, so it's been compressed vertically by 1/3. We have x minus 6 in the parentheses, so it's been shifted to the right 6 units, and then plus 2 on the outside of the parentheses, it is shifting up 2 units. I want to convert this to another form. I'm going to convert this to slope-intercept form. So I'm going to distribute this negative 1/3 in these parentheses, and I'm going to get negative 1/3 x plus 2. Negative 1/3 times 6 is positive 2, and then we have that other plus 2 right here. So now I'm going to simplify this. I'm going to have negative 1/3 x. 2 plus 2 is 4, so plus 4. So we actually call this slope-intercept form. I want to graph that function. We know that slope-intercept form is in the form y equals mx plus b. Hopefully that rings a bell to you. The slope is represented by m, and b is the y-intercept, or the point where the x value is 0 and b is just helps us to plot that point on the y-axis. The y-intercept is on the y-axis. So for this example we're given, the slope m is negative 1/3 and the y-intercept b is 4. So the point that we're plotting first is 0, 4. So I'm going to plot that first thing. I'm going to just look for 4 on the y-axis. Alright, so now the slope I'm going to look at next is negative 1/3. Now I'm trying to plot a straight line because we know linear functions form a straight line. So to form a straight line I only need another point. You only need 2 points to plot a straight line. So the way I've written this, the negative is next to the fraction divider here. Well, it's going to be more helpful if I write it like this. I'm going to say negative 1/3, or we can write it as 1/-3. Those are 3 different ways of writing negative 1/3. Now, slope is the rise over run. So the first way I wrote it, negative 1/3, the rise is negative, which means if we have negative rise, we're going down, and then we're going to go to the right when we run. We're going to go right 3. So check this out. I'm going down 1 unit and to the right 3 units. 1, 2, 3. And now what I'm going to do is I'm just going to draw a line through those dots. Alright, so now check this out. What if I used this slope instead? What if I went up 1, so the rise is positive 1, up 1, and then to the left 3. The run is negative 3. So up 1, left 3. 1, 2, 3. Well, that just ends up being another point on that line. Okay, so whichever way you decide to go to plot that second point is okay, as long as you're using the right method. This says to convert 3/2 y equals x minus 3 into slope-intercept form and then graph. So I'm going to rewrite this. 3/2 y equals x minus 3. And we're going to try to put that in slope-intercept form. Well, I want y to be by itself. So what I'm going to do is multiply by 2/3 on both sides to isolate y. 2/3 times 3/2 is just 1. So we want the coefficient to be 1. So what I'm going to end up doing is multiplying 2/3 times x and 2/3 times negative 3. So I get y equals 2/3 x minus 2/3 times 3 is 2. So minus 2. So to plot this, what I'm going to do is I'm going to find negative 2 on the y-axis. So negative 2 is b, it's the y-intercept. And then the slope is 2/3. M is 2/3. So what I'm going to do is I'm going to start at that point, that first point I plotted, and I'm going to go up 2 units because I'm rising 2 and running to the right 3. 1, 2, 3. They were both positive, the 2 and the 3, so it went up 2 and right 3. And there's the second point, and then we can just draw a line through those points. Voila. Now that we've discussed graphing linear functions, let's talk about writing linear functions. So first, if you're given 2 points and you're trying to find the slope, you use the slope formula. I encourage you to write down this formula. It's y2 minus y1 over x2 minus x1. We have y2 minus y1 in the numerator because it's the rise. The y values are the rise. And the x values help us find the run. So just think rise over run like you know slope to be, and it'll help you to remember the slope formula. Now if you're trying to write an equation given a point in the slope, so you're trying to write the equation of the function, you're going to use point slope form. It's y minus y1 equals m times x minus x1. Now you're given the slope, right, and just 1 point. So you're going to end up subbing the x value of that point into x1 and the y value of that point into y1. We'll work some examples applying these formulas. So this problem tells us to find the equation of a linear function with the slope of 4 and a point at 1, -1. Well, we're given the slope and we're given a point. So what we can use is our point slope form. We're given the point and we're given the slope. So the point slope form is y minus y1 equals m times x minus x1. And there we go. That's the point slope form. So what I'm going to do before I start is I'm going to say that the slope is m, so m equals 4, and the point is 1, -1 that we're going to use here. So I'm going to say that the 1 in the x value is x1 and -1 is y1 because it's in the y spot. So now I'm just going to substitute in to the point slope form. So we get y minus -1 equals, and we can put this in parentheses, equals 4, the slope, times x minus, now I'm substituting in for x1, and that's going to be 1. So y minus -1 is going to give us +1. So that's y plus 1. 2 negatives equals a positive. So now I'm just going to distribute this 4. So we're going to get 4x minus 4. Now, I want to have y on the left side by itself because we want this to be in the form y equals mx plus b. We want it in slope-intercept form. So we're going to subtract 1 on both sides, and we'll get y equals 4x minus 5. Now let's look at this problem. It says the graph of a function contains the points 2, 3, and -3, -7. What is the equation of the line? Now this looks really similar to the problem we just worked. The only difference is that instead of being given the slope in 1 point, we're given 2 different points. So what we need to do is to use the slope formula to find the slope between these 2 points first. So the slope formula is y2 minus y1 over x2 minus x1. Well, now I just want to substitute into this formula. But what I need to do first is do a little bit of labeling. This will help me a lot. If I say 2 is x1, that means 3 is y1. Therefore, -3 is x2, and -7 is y2. I'm just going to substitute into this formula to find the slope. So we get, let's see, y2 is -7 minus 3 over -3 minus 2. So m equals -7 minus 3 is -10 over, that's -5, which becomes 2. So m, the slope is 2. So I'm going to use the point slope form for this problem. Remember, it's y minus y1 equals m times x minus x1. And I already have x1 and y1 labeled here. So I'm going to say y minus 3 equals 2, that's the slope we just found, x minus 2. So I'm going to distribute this 2, and we'll get y minus 3 equals 2x minus 4. And then again, I want to isolate y, add 3, and we get y equals 2x minus 1. So I hope this video was helpful for you, and I hope it felt like more of a review from pre-algebra or algebra 1. If you have any questions, come to class prepared to ask them and prepared to work. Good work. Thank you, collegiate scholars. And by the way, go Tigers.